This is Professor Pelton. This is part 2 of Chapter 5, Section 6. So the last asymptotes we need to do is horizontal and slant. You either have one or the other. You cannot have both, essentially. So what you have to look at in the rational function is what's bigger. Is the leading term of the top bigger, or is the leading term of the bottom bigger? So numerator versus denominator. Okay, so we're going to use m for the bottom and n for the top. If the bottom is bigger, you're dividing by a bigger number, your asymptote is going to be y equals 0 horizontally. If they're equal, right, meaning they have the same power, they're both to the third power, they're both to the fourth power, you have to divide the coefficients, right, the coefficients, to figure out what the actual asymptote is. If the numerator is bigger, it's going to infinity, right? If the numerator is bigger, it's going to infinity. So at that point, you have to do long division or synthetic, whichever, to figure out this slant asymptote. So in two cases, you have a horizontal asymptote, which is when the bottom is a bigger polynomial or they're both the same polynomial. But if the top is a bigger polynomial, it's going to infinity, so it's going to slant up to infinity, essentially. You need to do long division at that point. Okay, so let's figure out the horizontal asymptotes and slant asymptotes for the following. Okay, so the following problem, the powers are equal. It's 2x to the second power and 3x to the second power. So that means I have a horizontal asymptote. So I'm going to do y equals 2 times infinity squared over 3 times infinity squared. Okay, so this is conceptual. So I don't need to worry about the non-leading terms. Only the leading terms matter, because when you're going towards infinity, the slower ones don't keep up, right? So the infinities cancel, so I'm left with 2/3. So the horizontal asymptote is y equals 2/3. So the slant asymptote doesn't exist. You have one or the other. Can't have both. Okay. So the next one, the bottom is bigger, right? Because it's the first power on the top, second power on the bottom. So that means you have a horizontal asymptote, correct? So y equals infinity to the first over 4 times infinity squared. So I get y equals 1 over 4 times infinity. Well, 4 times infinity isn't just infinity, right? But if I take any number and divide it up infinite times, I've basically blown it up, right? Take something and rip it apart into infinite pieces. You basically have nothing left as far as the size of the pieces go, right? So you essentially get 0. So the horizontal asymptote is y equals 0 graphically. And the slant asymptote, there isn't one, because you have one or the other. Okay, in the last case, the numerator is a higher power than the denominator, so therefore we do not have a horizontal asymptote, we have a slant. And you can prove that to yourself by plugging in infinity. So infinity squared over infinity to the first gives you infinity to the first over 1. Well, infinity divided by 1 is just infinity. So clearly there's no horizontal asymptote, right? So horizontal asymptote, right? None. None. So now we have to do long division, right? So x minus 3 into x squared plus 0x plus 3, right? Because they account for the missing term. So I'm going to multiply it by x and get x squared minus 3x. And we'll subtract. Again, you can do synthetic too if you want. It's up to you. But I'm going to do long division to show you a point. So 3x plus 3. Okay, so the next term I need to multiply by is a 3. So 3x minus 9. So that's going to be what? 12. Okay, so I have plus 12 over the x minus 3. But if I plug in infinity into here, right, that's going to be 12 divided by infinity minus 3. That's 0. So it doesn't actually matter. So the remainder is irrelevant. So the slant asymptote is y equals x plus 3. It's a line, which makes sense. A line is slanted, right? All right, pause the video. Try the student problems for yourself. Okay, so on the first one, what I notice is they have the same exponent top and bottom squared. That's the leading exponent, right? So that means there's a horizontal asymptote. So y equals 3 times infinity squared over 4 times infinity squared. So I get 3 over 4 when the infinities cancel, right? So my horizontal asymptote is y equals 3/4. So my slant asymptote is none. We don't have one. You have one or the other. And again, we're not doing vertical asymptotes here. We're ignoring that for now. We'll get to that later. Okay, so if I look here, the numerator is smaller than the denominator. So therefore, we're going to have a slant, right? Can you prove it to yourself? You can do y equals 2 times infinity to the 1 over 6 times infinity squared, which is 1 over 3 times infinity, or simply 1 over infinity. But any number divided by infinity is 0, right? Because you're blowing it up. You're doing it, putting infinite number of pieces. So my horizontal asymptote is y equals 0, and my slant asymptote is none. We don't have one. You have one or the other. Okay, so here, what we notice is the numerator is larger, so that means there is no horizontal asymptote because it's 2 times infinity squared over infinity. So that's 2 infinity over 1, or simply infinity. So there's no slant asymptote. So slant asymptote, right? None. Come on. Okay, so if I do long division, x plus 1, and we have what? 2x squared plus 0x minus 5. Again, I'm going to do long division, not synthetic, just to dictate something here. So I'm going to times it by 2x. So that gives me 2x squared. So times 1 is plus 2x. Okay, so I'm going to subtract now. So I get negative 2x minus 5. So my next multiple will be a negative 2. So negative 2 times x is negative 2x. Negative 2 times 1 is negative 2. All right, so if I subtract, I'm going to get a negative 3. That makes sense. Okay, so I got plus negative 3 over x plus 1. But if I do the negative 3, if I plug in infinity to this fraction, right? If I plug in infinity to that fraction, I'm going to get 0, right? Because negative 3 divided by infinity plus 1 is 0. Right, so my, whatever did I say? That's horizontal asymptote. Sorry, ahead of myself here. The horizontal asymptote was nothing, sorry. The slant asymptote, which I just calculated, right, is y equals 2x minus 2, right? Because it's going to infinity on a slant, and that is the slant, the line that's approaching. Okay, so let's put all these different asymptotes together to be able to graph rational functions. Okay, so we take this rational function here. What I notice is that the numerator and the denominator are not the same. The denominator is bigger. So as a result, I'm going to have a horizontal asymptote, correct? Okay, because if I do the leading terms, I get y equals infinity squared over infinity cubed, because I only need to look at the leading terms, right? So the leading terms are right here. Okay, so I get 1 over infinity, or essentially 0, right? So my horizontal asymptote is y equals 0, and the slant asymptote is none. I should have put the holes up with the vertical asymptotes. That would have made more sense. That's okay. All right, so if I factor this, I'm going to get x minus 2 and x plus 3. And on the bottom, you have to make the PQ list for the numbers 10 and 1 and figure out the factors. To save time, I've already done that. So this factors out to x minus 1, x minus 5, and x plus 2. So what you notice is the top and bottom factors have nothing in common, so nothing cancels. So that means there are no holes. However, we do have vertical asymptotes, right? Because these cannot equal 0, correct? So my vertical asymptotes are x is equal to 1, x is equal to 5, and x is equal to negative 2. All right, now we have enough information to make the regions of the graph. So y equals 0 is the horizontal. A little extra tail on that y. Okay, and my vertical asymptotes are at 1. Five, 1, 2, 3, 4, 5. And -2. Okay, so the last thing I need is the intercepts. So if I'm an y-intercept, the x value is 0. So y equals 0 minus 2 times 0 plus 3 over 0 minus 1 times 0 minus 5 times 0 plus 2, right? So if I think about that calculation, that's -6 over 10 or -2/5, right? So 0, comma, -2/5, right? There we go, because we know the x value in a y-intercept has to be 0, right? Makes sense, it's on the axes. Okay, so 0, -2/5 is approximately right there. Okay, so my x-intercepts, that's when the top is going to be equal to 0. Because if the top is equal to 0, the whole thing is equal to 0, right? It's essentially, at the end of the day, if you're an x-intercept, that means that the y is equal to 0, right? Okay. So what we have is x minus 2 equal to 0, and x plus 3 is equal to 0. So x is equal to 2, and x is equal to -3. So we have 2, and we have -3, 0, right? Because essentially, at the end of the day, this is also a y equals, right? And if y is equal to 0, you have an x-intercept. And if the numerator of the ratio, i.e. the fraction, is 0, then the whole thing is 0. So that's all you need to solve for, essentially. So I'm at 2 and -3. So 2, and I'm at -3. Okay, so this is more than enough information to actually graph this function. Okay, so each of these regions, something has to happen. So in this region here, it's going to approach the asymptote on this side. It's going to go down and cross the axes, and it's going to approach the asymptote on the other side. Because essentially, if there's an asymptote, it's approaching it. It gets infinitely close, but never gets there. Okay, so in the middle one here, it's going to go approach on both sides. And I know it doesn't go above the axes because we didn't calculate any more x-intercepts, so therefore it has to be down here. And it can't be on the top and the bottom because that would not satisfy the excuse me, that would not satisfy the vertical line test. Okay, so lastly, this one is going to go like this. Oops, I missed the point here. It's going to cross the x-intercept that I found and come back up. And it's going to follow this because it has to approach. It has to approach the horizontal asymptote as it goes to infinity. Okay, so the toughest one is on the right because it has to be up here or down here. It has to be one of the two. But it doesn't cross the x-axis because there's no x-intercept over there. So what you need to do is plug in a point. So over there, I can plug in something like 8, right? So if I plug in an 8, what happens? Well, if you look at the actual problem, it'll give you a positive value over a positive value, right? Plug in an 8, an 8, an 8, an 8, and an 8, right? Gives you a positive value. So it has to be up here as a result. So it's going to follow the asymptotes. You can do more tables of values to verify this is true, but it does in fact work. Okay. All right. Let's go into another example. All right, so in this example, now the numerator and the denominator are of equal value as far as the power. They're both x squared, correct? So that means there's going to be a slant asymptote. All right, so let's do the horizontal asymptote. So y equals infinity squared over infinity squared. So that actually gives you, so the coefficient is actually 1, even though it's not written, right? It's actually a 1, 1 and 1. So that gives me 1 over 1, which equals 1. So my horizontal asymptote is 1, which means there is no slant asymptote. And you can put that on here right away if you want. All right, probably should put that on this side, but that's okay. Okay, so I need to factor it now for the other part. So if I factor this, I get x minus 1, x plus 1. And on the bottom, I get x, x. So the factors of 3 are 1 and 3. And I need that to be negative and that to be positive. Okay, so those cancel. So I'm left with x minus 1 over x minus 3, which means I have a hole, right? So the hole, right, is at negative 1 comma something, correct? Because x plus 1 cannot equal 0, so you get x equals negative 1 for the factor that we canceled out right here, right? All right, so you have to plug it in now. So we get y equals negative 1 minus 1 over negative 1 minus 3. So that's going to be 2 over 4, because the negatives will cancel out. So 1/2. So 1/2. Okay, so I'm just using the actual function that I found to find the hole. Okay, so for vertical asymptotes, I'm going to get x is equal to 3, because the denominator cannot equal 0, correct? All right, so x and y intercepts. If I'm a y-intercept, then the x is 0, right? So y equals 0 minus 1 over 0 minus 3, so I get 1/3. Okay, and if I want to get an x-intercept, that's just when the numerator equals 0, right? So x minus 1 is equal to 0, so x is equal to 1, right? Because if this equals 0, the whole ratio equals 0, and that gives me an x-intercept. Okay, so I have a vertical asymptote at 3. I have a hole at negative 1, 1/2, so put a hole there. And I have a x-intercept at 1, and a y-intercept at 1/3. Okay. That's all the information I need to make this graph. So it's clearly going to follow the horizontal asymptote out to negative infinity. It's going to come down to here, cross the axes of these 2 points, and then follow the vertical asymptote. So on the right-hand side, it has to be either up here or down here, right? It's going to be one or the other. Well, I can tell you right away without plugging any values, it's going to be up top. Since it didn't actually cross the x-axis over there, it's going to be up top. Otherwise, I can just plug in a value, right? Plug in some value that's high, like 8. So if I plug in 8, I'm going to get 8 minus 1 over 8 minus 3. That's a positive value, right? So that means it has to be up here, essentially. So that is my graph. All right, that is the end of part 2.